Ready? Again, okay. 50 volts, 5 ohms, 2 ohms, 5 ohms, 10 ohms, 5 ohms, 5 farads, which is looks really bad, and then just some arbitrary L because it really doesn't matter.
Yeah, it looks like a 6.
Well, God, okay, fine. 5. It's as good as I can do. I have terrible handwriting. Deal with it. Let's see. So we have the circuit below consists of one battery plus the resistors, all these things. What is the current flowing out of the battery at t equals 0? That's not too hard. We can just use the rules that we've already found out. So what are the rules for inductors? So you can write that down up here. So for inductors, what are they at time 0? Ignore, yeah.
But it still has voltage.
Yeah, so t equals 0, blocks current. And then t goes to infinity, straight wire, right? That's the worst infinity sign I've ever made in my life. That is saying something. Okay, so capacitors. Opposite of above. There we go. Those are our rules. So inductors block the current at t equals 0. Capacitors block the current at t goes to infinity. That's all you gotta know right now.
So when it's a straight wire,
Just act like it's not.
the resistor, right?
What?
When it's a straight wire,
You count the resistor. If it's a straight wire, so like at t equals 0, you will count R5 but not R4.
Okay.
And the other way around at t goes to infinity. So when something blocks current, ignore that resistor completely. If it's a straight wire, include that resistor. It's basically like the whatever it is, either the inductor or the capacitor is not there. Okay, so t equals 0. Here we go. Let's get into some stuff. T equals 0. We need to find current. That means we need to find equivalent resistance. So t equals 0, we can ignore branch R4. Ignore the branch of R4 because L1 is blocking that current. Okay? So t equals 0, ignore branch R4. That means we can now find R3, 5. That equals 1 over 2 plus 1 over 5. I have no idea what that's going to be. Come on. Oh, there we go. 0.5 plus 0.2. Something like 1.43 it looks like. Did everybody get that? That's 3.5. Okay, I have terrible handwriting. We've discussed this. Okay, so what did you guys get for R3? 1.43, something like that? Okay. Good enough for me. 1.43 ohms. Okay, and then our total is just going to be R35 plus R1 plus R2. What?
our total. I was giving you a number.
Oh, what'd you say?
11.43.
Okay, perfect. Yeah. So our total is 11 point. It's like, wait, what? What did I do wrong? Stop it. Okay. So 11.43 ohms. So sorry, my numbers aren't very good, but that seems to be life most of the time. So your current in this case, so I total will be
4.3.
yeah, 50 volts divided by 11.43 ohms, which equals what?
4.38.
4.38 amps.
Wait, how did you get our total? Did you add the?
Okay, so let's see.
The 1 and 2 in parallel?
Yeah, so no. So 3 and 5 are in parallel, and then 1, 3, 4, and 2 are all in series. So if you just walk through it like R1 to R2 or R3, 4 combined, R5, well not R5. Sorry, R3, 5, thank you. So R1, R3, 5, and then R2 all are in series. This small loop. Yeah, I promise. Okay, yeah, so these three are all in parallel, and then their equivalent resistance will always be in series with these two. These are not in parallel, I promise you. Okay, so that was our current. Yeah, okay, so that's the current at t equals 0. What is the current at t equals to infinity? Okay, and then he asked, what is the ratio of voltage drops across resistor 1? Okay. So I guess we can find, we need to find 2. So t goes to infinity. Let's do that.
Wait, so we're not gonna find
We will. Just give it a minute. Okay. Who gave me this shiny stuff? Okay. T goes to infinity. Now what is being blocked? 5. Perfect. Okay, so we are going to do R3, 4 because 3 and 4 are in parallel, and that's going to be 1 over 2 plus 1 over 10 inverse 0.5 plus 0.1 by 0.6. I got like 1.67. Okay, gonna go with that. So 1.67 ohms. That means our total is going to be just that plus 5 ohms plus another 5 ohms. So 5 plus 3, 4 plus 2. So or R2. So that's going to be 11.67 ohms. Not a huge difference from last time, but it will be a difference. So I total equals 50 volts divided by 11.67.
4.29.
Wow, this is going to be the most infinitesimally small difference ever. Didn't know that would happen. Whatever. It's fine. Should be a difference, and that is not a delta. Just saying. Okay, so that's the easy part. So 6 and 7 are pretty easy. So the ratio of voltage drops across resistor 1, then resistor 2. So I'm going to do resistor 1 and resistor 3 because resistor 1 and 2 are going to be exactly the same. So we're not going to mess with that. So what is the difference between voltage drops on R1? So that we're going to say R1. So VR1 here is going to be, we'll have the full amperage coming out at this starting point. So once we reach this 5 ohms, all we'll have to do will be 5 ohms times our total amperage, which is 4.38.
21.9.
21.9. 21.9. Come on, folks. Okay. We have our one here. It's just going to be the same thing, 5 ohms. You get there? Okay, 5 ohms times 4.29.
21.45.
That will be like the smallest ratio difference you'll ever see in your life. So I don't know what he's what he'd do there. He'd probably say it's something close to 1. But it'd be 21.9 divided by 21.45. So I don't know what that is. 1.02. So yeah, that's good. That's outside of 1%. So he might actually do. I don't think he did that. So our ratio would be ratio of R1 will equal 1.02. God, this thing really should be better. Okay. So now we need to find our voltage from R3. So we're doing R3 instead of R2. You get R3. Okay. So let's see. So what you're gonna want to do is a lot like we did in class today. You're gonna want to find the voltage at this point and at this point. So here's A, here's B, and that will give you the voltage drop across 3. Okay. So we already found that here 21.9 volts has been lost across R1. So 50 minus 21.9 is 28.1. I'm afraid this isn't going to make sense. Yeah, no, it's still going to make sense. Okay, so 28.1 volts here at the first time, and then you'll also have 21.9 volts coming out of coming through R2, since it's the exact same as R1. So point B will be 8 point. That's 50 minus equals 6.2. So at this point here, you'll have 6.2 volts. Or that's the difference. What am I doing? Sorry. That was absolutely terrible. At this point B, you have, so it's like 28.1. Here should be 21.9. Sorry. The difference is 6.2 volts. So V of R3, sorry, equals 6.2 volts. So, sorry, I need to explain that a lot better. So, to find the voltage across R3, you need to find A and B. So, the voltage at A is just 50 volts minus 5 times 4.38, which is 21.9. So, 50 minus 21.9 was 28.1 volts. Which you probably can't see, but sorry. And then voltage at B is just 0 volts plus whatever voltage that you have coming through here, which is 5 times, once again, 4.38 amps, which is 21.9 volts. So you go from 28.1 volts to 21.9 volts through R3. Sorry, it's really hazy. And that gives you 6.2 volts. Okay, so that's for t equals 0. And then
Isn't there another way to do it that he used in class? Just 5 times R?
you'd have to split I at A.
Okay.
So that'd be a little confusing.
I found the same answer just using I times R.
I times 2. Wait, really?
Yeah, I just did the current times the resistance as.
Oh, the equivalent resistance. Right?
Because we got the same.
Oh, that makes sense. You could do it that way. It didn't work that way in class today because there was like another parallel thing or something.
Inductor.
Was there something else?
Well, he was asking.
Oh, because he's asking for the inductor. Yeah, so that's confusing. So yeah, you could also in this case just do that also equals to R34 times I total. So that's another way you can do it. You should always be able to do it with like this A to B method, but in this simple case where everything's in series and he's only asking about resistors, you should be able to do it just I times the total, like the equivalent resistance here. So I don't know if that'll work on the test. I don't. I know the finding the A and the B will work because that's what he did in class and showed people like that. So I don't know. It is easier that way, but yeah. So in a similar manner, you'll end up with at point A here, you'll end up with 50 minus 21.45. Oh yeah, that makes sense. Yeah, so here you'd end up with 28.45. What? 55, right. Okay, seriously. This is running out of ink, that's good. And then down here you'll end up with 21.45. And here, 21.45. I honestly think it's just this projector thing, but no, never mind. And so you end up with something 7.1. So we said. So you end up with 7.1. I can't write anymore, so we need a pen. That works.
Oh.
Please don't ever go on the Royals. Okay. 7.1. This is 21.45. This was 28.55. Okay. Yeah, so you end up with 7.1, which is also the same thing as equaling the R34 times I total. That would also work, once again, in this case. What else? And then I don't even know about 10. So if